You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you. Hello, this is Richard Jacobs with the Future Tech and Future Tech Health podcast. I have Gary Marcus. He's an author of a book called The Algebraic Mind. And we're going to be talking about the transition from human-level intelligence to artificial intelligence and to artificial general intelligence, meaning AI that can do everything a human can do and more. So, Gary, thanks for coming.
Thanks. Of course, I'm also the author of the new book, Rebooting AI. The Algebraic Mind's an older book, but in some ways they have a similar theme.
What sparked your interest in AI in general?
I've been interested in AI since I was a kid, since I was 8 years old, and I first learned to program a paper computer. And ever since, I've been interested in how you make machines do smart things. I worked a bunch on AI as a kid and actually got into college early by writing a Latin to English translator. Then I abandoned AI for a number of years, focused on human cognition, and now I've returned, kind of taking what I know about cognitive development and how children learn and trying to apply it to AI and try to make better AI.
No, interesting. So what, overall, what are your thoughts about artificial general intelligence? And, first, if you can define that, and then, is it a possibility? And if so, are we close?
I think it's hard to give a strict definition to anything. I mean, 20th century philosophy showed that we can't even give a perfect definition of a chair, because some chairs have four legs and some don't, and you've got beanbag chairs. And so I'm not a firm believer in strict definitions, but I think the key word there is general. We have lots of intelligence right now that is narrow. So we have chess playing computers and Go playing computers, poker playing computers that do one thing and don't really even have that much context on that one thing. And they can't do anything more general than that. So, the Go playing thing doesn't actually understand that there are stones on a board, doesn't understand that there's life beyond that board. And what general intelligence would be about would be building machines that can figure stuff out for themselves and can cope with the reality of an ever-changing and complicated world. So general intelligence would be about seeing something new, like a new political situation, and being able to analyze that, as opposed to just doing the same thing with the same rules over and over again. Do I think it's possible? I certainly think it's possible in principle. I mean, you could argue that humans don't have fully general intelligence, but we have pretty broad intelligence that allows us to do many different things, whether we're talking about law or entertainment, anything, that any piece of human endeavor requires the kind of general intelligence that we do have. That doesn't mean we're all able to reason about quantum mechanics, but most of us can do many things reasonably well. And we don't have machines that can do that yet. I think it's possible in principle to build such things. It's certainly possible in principle to build a physical machine that has general intelligence, because the human brain does that. We can't do it now, though. And a lot of what the new book, Rebooting AI, is about is specifying all the ways in which we actually fall short and trying to be more precise about what we would need to do. So the techniques that people are excited about right now, like deep learning, are very good at learning categories of things, but they're not very good at reasoning, understanding language, and so forth. So realistically, we have a long way to go before we get to something like artificial general intelligence.
Yeah, it seems like, again, AI can do very narrow tasks. And I guess for now, people are maybe stringing together various narrow AIs to make it seem like they have a more general intelligence about them. But what do you think would be necessary to make this jump?
I think it's actually a huge leap. So I'll go back to something you said a second ago. It's possible to fool people by stringing a bunch of narrow intelligences together. So we've actually known that since 1965, when Eliza was a kind of early chatbot that fooled people into thinking it was much more intelligent than it really is. So it just matched keywords. You'd say something about your mother, and it would say, well, tell me more about your family. And people got fooled by it. So We're relatively gullible species. If we see a little bit of sign of intelligence, we think that there's more intelligence there than really is. And what happens is we wind up with AI that we shouldn't trust, but that we do trust. And a good example of that is a driverless car. You drive it for a few hours and, a Tesla on autopilot, and you think that you can trust it, and you can't really. And so some people have wound up dead because they gave it more trust than they should have.
When you said they've given it more trust than they should have, like, what's an example? Are there any stories that come to mind of what happened with the Tesla in particular?
The most famous story is the first accident in Tesla. A guy was watching Harry Potter in the back, and the Tesla drove into a tractor trailer that was taking a left turn on a highway. So it appears that the Tesla thought that the tractor trailer was a billboard because someone had written some very hacky code. I've never seen this confirmed, but this is the rumor in the industry. Someone wrote some hacky code to make the machine stop slowing down every time it saw a billboard, and the machine then thought that the tractor trailer was a billboard. So, none of the self-driving software has been fully debugged, and yet you have people who think it's okay to trust the car to drive. And we have people who have fallen asleep in the Teslas. That first accident I described was about 3 years ago, and then a very similar fatal accident happened earlier this year when, again, somebody in a Tesla on autopilot that was presumably not paying attention wound up basically running underneath a tractor trailer and dying.
Right. So you said it would be a gigantic leap to get to AGI, but again, what are some of the steps along the way that you envision making it possible?
The place where we are, to understand the steps, you have to understand where we are now. Where we are now is we have machines that take a lot of statistical data, big data people call it, and make guesses about what's going on in the world. But they don't really represent the things that populate our world, objects, people, windows, trees, and so forth. The machines don't really understand those. We have to make a transition from this thing that people call deep learning, which is a particular algorithm that extracts statistics, to what I would call deep comprehension, which means that systems have to build models of the world sort of inside their silicon and the data representations and so forth that allow them to know which things are where and what those things might likely happen. They have to understand causality, that A can cause B, and that being correlated between A and B is not the same thing as A causing B. So we have to focus on fundamentally causality, having machines represent things like space and time, individual objects. If you go back to Immanuel Kant's critique of pure reason, he argued that if you didn't start with space, time, and causality, you would never learn them just by exposure to the world. You need some kind of bootstrap in place in order to allow you to learn more about the world. And I think Kant was exactly right about that.
So how could the machine intelligence even be aware of all the necessary things? It seems like we'd have to take a reductionist approach. Maybe starting out an AI in a room with two different types of objects, or a room of people. I don't even know how you would start to show it what it needs to learn.
I think that the assumption that you're making and that everybody makes is that it will all be learning. And I think that the right thing is not everything to be learning, but for some things to be learned, but also to have a very rich, innate, built-in starting point. So if you look, for example, at a baby mountain goat climbing down a mountain a few hours after it's born, not everything that mountain goat is doing is learned. In fact, a lot of it is built in. So the mountain goat is born with an understanding of three-dimensional geometry, of how to use its own body to climb, of how to interpret the things that it sees. And yes, the mountain goat learns some things, but it has to know enough within a few hours of its birth to be able to scramble down a mountain and not fall off the mountain. So people are very touchy about how much innateness they think a human mind might have. But if you look at other animals, it's just obvious that the genome is building a rough draft of a brain. We need to be making our AI in a similar way. We need to have a rough draft of the psychology that it needs to have in order to understand the world around it. Then once you get started, you can learn a lot. If you already know that objects exist in the world, you can try to identify particular things as being particular objects. If you already know that people exist and they have different properties and temperaments, you can start to learn about those properties and temperaments. If all you have is a bunch of pixels and you're just trying to learn everything by kind of trial and error, the problem is too vast and too complex. And that's what people have been doing lately, and the systems are just very brittle. They'll work in some tiny laboratory demonstration and they break down over and over in the real world. So I think that what people want to do is to just throw the robot out there, robot being an AI system inside of a physical creature, and let it learn everything for itself. They don't want to do the hard work of saying, what do we need to know about the world from the beginning in order to make that learning process easier? What my colleague, my co-author, and I, Ernie Davis, and I have been arguing is actually it's not going to be that simple. We're going to have to spend some time figuring out how things like space and time and causality can be explained to computers, rather than making them just learn all of that, because they're not learning that just from experience.
Yeah, that's what I mean. How do you teach a concept to a computer? What does a concept look like if you encapsulate it in code? I mean,
Well,
it seems like AIs are just mathematical optimization machines. That seems like what they are to me.
Well, what you're leaving out there, and what a lot of the field leaves out, is logic. So the current systems are just doing optimization of parameters that try to predict statistics. And other tools, like the logic that allows most of the world's computer programming to work, is not really there. So one has to, I think, program some things and optimize others. To kind of use the way that you're talking about things. So every computer program is essentially an exercise in logic. It can always be translated into the truth tables that logic are built out of. And so you can program in that I'm going to, for example, have a database with this structure. There's going to be a first name and a last name and a address and a phone number and so forth. And so you can say, even in advance of experience, this is going to be the structure of the world that I anticipate, and these are the things I'm going to do with information that is structured in that way. And classical artificial intelligence is very much interested in the problem of knowledge representation. How do you translate information from the world into representations that the machine can use? And that whole field has sort of gone away, and it's very hard and difficult. Nobody really wants to do it. The one real approach to it was done by Doug Lennett, who spent 30 years building a system called Psych, where he paid logicians to translate things essentially into the language of logic. And that started in 1987. I don't think it's been wildly successful, but I think that we need to do something of the flavor of what Lennett did, using more modern techniques. So when he did that in the 80s, we didn't know much about how to teach systems about statistics and probability and really about learning for themselves at all. So it was all hard-coded. What we need is some kind of compromise where we don't hard-code everything. We do some learning, but we also have some rich knowledge representation at the beginning.
Is the framework even in place? Is there a coding language or types of algorithms that can do this? Is there a chip that supports both fixed code and a space for learned and added on code? I mean, what would this look like?
I think we're missing some basic ideas, but we have some things in place. So I don't think it's a matter of building a new language. I think all computer languages are ultimately equivalent, and if you want to write it in Python, you probably can. And you might use some TensorFlow, which people use nowadays for neural networks to do things on the perceptual side of things. I don't think it's a problem at that level. I think it's a problem at the algorithm level, and a problem at the knowledge representation level. So there's a famous book that says, the title is something like Programs Equal Algorithms Plus Data Structures. And that's saying that for every program, there's really two problems you have to solve. One is you have to figure out, how am I manipulating this data? So I'm going to compare this, and I'm going to store this in this register, and I'm going to call this subroutine and so forth. That's the algorithm side. And the other side is, how am I going to even store the information that I want? So I'm going to use 8 bits for each character, the ASCII code, or I'm going to use a bitmap to represent a picture, and so forth. We need the equivalent of that for knowledge, and people haven't quite figured that out. That's where I think the work is in making richer knowledge data structures and then interfacing them with algorithms. Right now, most people are working on the algorithms. They're not really paying a lot of attention to the data structure, or what some people call the representational problem. And we need some new advances there. And because it's so easy to play with the deep learning algorithms, that's where everybody's attention is. But I don't think that's where we need the attention to be. I guess it's sort of like asking, it's sort of like asking pre-Isaac Newton, like, how does all this stuff work? Like, we need some foundational advances that just aren't there yet. We don't have the conceptual tools yet, I think, to really make an AGI. It might be that somebody has written some academic paper that's nobody's noticed yet, but there's nothing in commercial production that really looks like the things that we need yet.
Well, what would a conceptual tool? I mean, what would a tool look like? What's your conception of what a tool would look like? Just a part of this.
I would say that my conception is that we need tools that bridge together neural network kind of optimization techniques that have become popular lately with classical AI techniques where you can store things roughly as English sentences. They might be a little bit more formally specified, like in logic, or they might not be. They probably have to have some statistical representation. And then we have systems that, or we need, I should say, systems that merge these things. And nobody quite knows how to do that yet. But we need, conceptually tools that can bridge different kinds of knowledge and information. Another way to think about it is right now, people have neural networks. They don't know how to use those neural networks on existing databases of knowledge. So let's say you want to teach a system how to recognize a zebra. One way to do it is to show it a lot of pictures of zebras. But I could tell you how to recognize a zebra by saying it's a horse with stripes on it. So I could tell you that verbally. And we don't have something that can kind of translate between the pixel representation, the picture, an image, and the sentence-like representation. That's where we need an innovation. Right? So you can feed in, a deep learning system a bunch of characters telling about horses and stripes, but it doesn't know what to do with that. Take another example going the other direction. I can show you a picture of a school bus turned on its side that a deep learning system will tell you is a snowplow. And the deep learning system isn't able to incorporate information like a snowplow should have a plow on it. And it's really just recognizing the texture of roads that have snow on it tend to have snowplows. So it's misled by the statistical correlation. And it doesn't have the conceptual underpinnings to know what a snowplow does or what the three-dimensional geometry of it would be, such that it could turn on its side, or the school bus could too. We don't have systems that bridge those types of information, the visual information and the verbal information. That's what we need.
What if there was a system that you train it on a dog, a cat, a horse, and this and that, the other? If it was able to hold and retain what hundreds of different types of objects were, maybe by doing a gigantic picture library of each. And then you had another system that would make associations between them.
Well, that is kind of what deep learning does. It memorizes a lot of pictures that are labeled. And then when you show it a new picture, it tries to guess what it's closest to. And if I show you a bunch of pictures of elephants and I show you a new picture of an elephant that looks a lot like those, the system will probably get it right. If I show you a silhouette of an elephant that doesn't really have the same texture as the others, it probably will get it wrong. And the other part of what you said, well, could you just associate this or that? People don't really have a way to do that with the verbal information. They can do things like throw in sequences of words, but the systems don't really understand what those words mean. And so their ability right now, not saying forever, but right now, to leverage that information is pretty limited.
Yeah, it's a weird puzzle. I don't even know how you would, I guess it's that missing essence. I don't even know what you'd call it, that allows our brains to work. I don't know. I don't know how
you could look for neuroscience for an answer, but unfortunately, neuroscience doesn't have the answer yet either. So, a question you could ask would be, how does the brain represent a sentence? And if we knew that, that might help us a lot with the AI stuff. But we don't have animal models of how language works. We can't really record from a lot of neurons in the different language areas because we don't want to crack people's skulls open to do the studies, and we shouldn't. And we can't do deprivation studies the way that people might sometimes do in birds to understand how their systems work. So our scientific tools for understanding how language is represented are, at least at the moment, fairly limited. And so we don't yet have insight from the brain into how to do these things. We might someday, but my guess is we'll actually crack AI before we crack neuroscience.
I don't know. Are there any interesting theories out there? Is it at least at the theory stage of how you'd figure this out? Or, where do you take this from here in your own mind? Where do you go?
My sense is that we have to start by being honest about what the problems are. That's what the new book is about, Rebooting AI, is trying to pinpoint the particular places where things work and don't. And I think that we need to have a realistic estimate. So the opposite is you just sort of say, well, we'll just get more data and all these problems will solve themselves. And my view is that that's not true, and problems are not solving themselves. We've made enormous progress on chess and Go, but almost no progress on natural language understanding. So machines in the 1960s couldn't really understand what you're talking about. Machines now can. Machines in 1960 couldn't read. Machines now can. So I think we have to start by being honest about the problem and then diving in and saying, well, which aspects of particular problems are solvable and not? So here's an example. I could ask you, did George Washington own a laptop? And you're not going to memorize the answer unless you heard me talk about it before, right? It's not like you read the answer in a book, but you can figure it out. Did George Washington own a laptop? Tell me.
Right. No, there's no way.
No way he owned a laptop. Well, why do you say there's no way he owned a laptop?
Because he existed at a time before laptops were around.
Exactly. So that's a natural inference for a human being to make. And then you can ask, well, what does it take to get a machine to do that? So some pieces of it are actually easy to represent. So you can tell a machine a rule about, if somebody exists at time A and ceases to exist at time B, and something else is introduced at time C, then such and such follows. But you do have to think in advance to program that rule, and there's a lot of them. And so people have gotten stuck trying to find the right sets of rules. And then you have to be able to integrate, even if you've got those rules, suppose you do have that rule, you have to be able to integrate all the information. You have to figure out when the laptops were there, and you have to plug it. Essentially you've got like an algebraic equation in your head, and you've got to drop the right things in. It's kind of a fancy math problem in a way.
What's even worse is if you ask the computer, what color was George Washington's white laptop?
It might not even get that because it doesn't. That was a weird one because the answer is not well defined, right? It's a sort of trick question. It's like, how many animals did Moses take on the ark? And it's a trick question because Moses didn't take any. But there's a lesser version, which is like instead of George Washington, would say, if John Lennon had a laptop that was in his all white room, what color would it be? Now we're doing counterfactual reasonings. John Lennon probably didn't have a laptop because there weren't really that many in 1980 when he passed away. And so kind of unlikely he had one. But if the room is all white, you can infer from that what he would have done if he had. And we just don't have systems that can do that yet. But I think it's important to understand where the limits are so that we can figure out what would be better.
Yeah, that's a really tough question.
It is a tough question. I mean, I think, all the best minds in AI have at least thought about these things a little bit. Right now, I think that they're, and not come up with an answer. I think right now they're distracted by a shiny new thing. So not enough people are thinking about these hard questions, but we need to if we want to move to general intelligence.
Yeah, no, definitely. Timelines, what do you think? Any guesses on when do you sense a breakthrough is coming? It's just a matter of time. Do you sense
I think breakthroughs are hard to predict. Historically, we're not that good at predicting when they will come. I would say that the single biggest problem right now is people are looking in the wrong direction, but that could change quickly. I think once people realize the limitations of the current systems, they're going to start looking for other things. A lot of money invested right now, much, much more so than historically before. And so there's some energy there that might get directed towards the right kind of questions. And things could change rapidly. I think, we're not going to see general intelligence in the next 5 years because there's just not enough there. It's possible if things really all lined up that we could see it in 10 years. More likely it might be 20 or 30 or 50 or something like that. The problems are really quite difficult. Notice I'm not saying 100 or 200. Like, I think we will solve them, but, we need something else. And be sort of like, in the early 1900s, Mendel had said that there were genes. He called them factors, but nobody knew what they were made of. And it would have been hard in 1910 to say, when are we going to discover what genes are made of? And most people around that time thought that they were made up of proteins. And so they were looking at lots and lots of proteins. And DNA is not a protein, right? And it took a while for people to stop looking down the wrong avenue and start doing careful process of elimination experiments that Oswald Avery did, to realize that it was this weird DNA molecule that wasn't even on most people's radar. And so I think we're in a similar situation where there's a lot of groupthink. Instead of everybody thinking that genes are made of proteins, they're all thinking that the answer to AI is in deep learning. We need to get off of that in order to look at the right avenues. Nobody quite knows what the right avenues are yet.
Yeah, interesting. I don't know, is it exciting to you, the generational adversarial networks that, it seems to be a different type of AI?
They're cute. They're very good at making things like fake images. They're going to have some practical real world import because they're going to start making fake news. And they already have. And so I think there's some practical import there. It's going to make a kind of AI that can fool people that's very difficult to defeat. However, I don't think it's really general intelligence at all, and I don't know if it's meaningfully contributing to general intelligence. It's a really neat way of synthesizing visual materials, auditory materials. So it's got some practical import, but I don't know that it actually bears on AI per se, or on general AI per se.
Okay. Well, very good. So, Gary, what's the best way for people to find out more from you?
Well, there's a lot of information now at the website for my book, Rebooting AI, that has excerpts from the book that have been published in Wired and the New York Times and elsewhere. And so that's a good sense to get a flavor of the things that I'm talking about. And you can follow me on Twitter at Gary Marcus.
Very good. Well, Gary, thanks for coming on the podcast. I appreciate it.
Thanks very much for having me. Take care.
You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.